Hi, in this session we'll understand how can we remotely provide an OTA update directly from our GitHub account. So in this we'll see the disadvantages we had in the previous ways of doing the OTA and how can we resolve that issue here and how does this particular thing helps us to make the things a lot easier. How can we remotely check it? Might be with the event based or might be with sending a command or might be putting in a loop that every Sunday or every day at morning 4 o'clock it checks for the update and so on. So this particular thing plays a very important role whenever you have a device in a production field or you do not want that device to be frequently bought and connected to the laptop and so on, and you just want that things to be resolved. Might be you want to add a new feature, might be you want to add a new component into it via the software, some logic implementation something, or you have some bugs which you figure out later and you want to optimize your code, or might be for any other statistics or any other improvements you want to update something. So in that scenarios what you can do is you can quickly and get this thing being done. So this would play a very important role in getting our things a lot much easier to update over an Wi-Fi or over an air. In the earlier two ways, we had seen a basic OTA and we have also seen a OTA over an Wi-Fi, but the restrictions we had was that we need to have the device or a ESP32 development board connected to the same network where you are at. In normal scenario, that doesn't become a case. We may have our production device or we may have our ESP32 board connected to some other different network and you might be somewhere else. Imagine that you have left your device here and then you had to go to somewhere else and then you think, okay, you wanted to have one more update or you wanted to close the lights at some earlier position or something else, or you have to have a complete different scenario. Might be you have a monitoring a plant and it needs a water every day at 7 o'clock, but now it's already rainy and you do not want to do that thing, so you want to stop it. So might be you can do with giving some commands over an MQTT, or you want to update the complete firmware so that it performs that thing in regular routine. So this will help a lot into this thing. So here we'll understand that in much more detail. So we would require a GitHub account wherein we would implement that GitHub account, link that particular file here and then see how it works. Before we start, let us segregate how we will be learning this thing. So firstly, we'll see what are the requirements we need for this. Secondly, we'll see how will that work, how the operation will work. And thirdly, we'll also see how does it work in real by implementing the same thing and checking out the scenarios in how it works. So firstly we need is a GitHub account and the file which you want to provide after an update. So when you want to give an OTA, the file which you have, which is nothing but a bin file, we'll learn how can we create a bin file so that we understand that in a better manner. So here we go. Now this is my sample program. Here we have basic with OTA GitHub. So we will require a Wi-Fi library. We'll also be requiring HTTP client because we're going to do all of this thing with the HTTP and HTTP update, which will monitor and take care of all the HTTP related update queries and handling that complete file, that is getting that payload and then rebooting with the new firmware, and all of this thing will be taken care by this. And then we have a certificate.h, cert.h, so we are including this thing. Why do we need this? Is because GitHub is a secure website, so we require the certificate provided into that thing. So it remains the same, you can just have the file from the description below, so that remains the same to all the GitHub's account. You can just use mine and it works perfectly well. Then below that we have an SSID, that is my Wi-Fi name, and I am providing my Wi-Fi password. And here in the status, I have created a status variable here, and I'm just checking out this idle status of that so that I can handle the disconnection of the Wi-Fi better way. And then I have an incoming byte, and this incoming byte is to receive a command from the terminal. For now we'll just see, once we receive a command from the terminal, it should work out. So when I press some button, when I give a command, that should come as an update. I mean, like, it should read that command, and then based on that, if it is matching the character, if it is matching that string, then based on that it is going to update or check for the update, and then if update is available, then it will update the firmware and load the new firmware. And here I'm providing a string firmware version, and here I have is 1.2. I'll just change this to 1.0. So why do we need this is because this particular firmware is 1.0. So in the next one, we'll give a new firmware. So when it is checking for the firmware version, it should get to know, okay, this is a 1.0 currently we have, and if the next one is different than that, that is anything different than that, then I get to know, okay, there is another version, there is a new version of the firmware, so I need to download that. And then I'm defining the firmware version. So this is my file path. So if I just go back to here, so I have a file here, bin version text. So this has a text of it. So currently it has 8.2. I can edit that and make any changes if I want to. So I'll just change this current right here. So 8.2 I have, I'll just make it to 2.0. Okay, I'll just make it to 2.0 because I already have 1.0 there. So I'll just change this. So I'm done with this, and I'll just commit the changes here. So now this file is being changed to 2.0. So now it has 2.0, which is different than what we had earlier, that is 1.0. Okay. So now the link, that is a path to this version.txt, is provided here in the URL firmware version. You can see this. I have URL firmware version here, version.txt, and in the other file, I have one more thing, is bin firmware.bin. So this is a OTA file which is going to be downloaded when it is checking for the available update, and if it has available update, it is going to do that. So how do we get this bin file? So we'll learn that. So before going to create a bin file, which we have into other program, we will be creating another program wherein we will make some changes and then make a bin file of that, upload that bin file to the GitHub, and then get the things being done. Then we have a setup part where I'm just printing a active firmware version, getting that firmware from that is 1.0, starting the serial communication at 115200 baud rate, connecting to the Wi-Fi with the provided credentials, SSID and the passwords. Printing connecting to Wi-Fi and just a Wi-Fi handler here. I'm trying to connect 10 times if it in case doesn't get connected, and after the 10 times elapses, it's going to restart and then try to connect again, because so that it is much better to handle and easy to handle if it doesn't get connected. And if it is connected, I'll just print it connected to Wi-Fi. And in the loop part, I am printing active firmware version with 1 second delay. And if Wi-Fi is not connected, then I'm calling a reconnect, and this reconnect is going to give me try to connect the Wi-Fi again by same thing, that is, it'll try to connect again for the 10 times, and if it doesn't get connected, it's going to restart the ESP32 and then try to connect again. Then we have if serial available, that is, if there is something available in the serial monitor, then if the incoming byte is U, that is update. So for now I have given U here. You can give anything you want to, or you can also check it via different ways, which we'll see in the upcoming videos. So currently I'm seeing if I press U, so it's going to check out firmware version. So if the firmware version is changed, or if it is a new firmware version available there, then it's going to update and download the firmware. So I print firmware update in progress and then firmware version check. I'm calling a firmware version check, and if this is returning 1, then I'm calling the firmware update, which will handle the update part. So let us see what do we have in the firmware version check. So if I go to that implementation there, so I have this method here. So this is going to just create a string payload and HTTP code, and here I'm trying to request the firmware URL from where I just get if I have a thing being changed, that is, if the firmware version is received here, you can just see here start connection and send HTTP request. So if the firmware version is received, then we change that, we save that particular firmware version and then pass out, because it will be a new version, and then we'll later compare if that version which is being saved and the version which is being found in that file is not matching, that is, it is a changed one, then we try to call the firmware version update. So now, and else if that doesn't happen, then we'll just print error occurred during the version check. Error occurred during the version check. So if HTTP code is okay, that is if the version is received, we are successfully able to receive the version, and if the payload, that is the thing which we have read in the firmware version, is read, and if that one and the firmware version which is stored in the program is equal, that is 1.0 even here, 1.0 even there, that means it is equal, then we print the firmware version is already updated. If it is not equal, then we print new firmware version detected. New firmware version detected. So this is how we are handling the firmware version check, wherein it's going to check the firmware version.txt file and compare the payload from the firmware version check which is present in the program, that is 1.0 and 1.0. If it is same, then it's going to print no firmware is already updated, else it's going to print new firmware detected. And if so happens, then I'm going to call if firmware update. I'm going to call a firmware update, and in this firmware update, what I'm going to do is I am just going to go to the same link again. So I go to the firmware version bin. This URL I'm going to go, and then get the content of that URL. Get that bin from there. Get that bin from there, and once I get that bin, so let me go to this implementation here. So I have a firmware update here. So Control F. So here I have this firmware update. So here I'm just trying to go to that particular thing website, that is go to that particular link with my root CS certificate. So that's why we had included a root CS certificate here, and then try to get that file, call the HTTP update to get that thing being downloaded, and then update the ESP32. And if we have some if we have some errors, then if it is failing, then we print HTTP update failed and followed by the error why it is being failed. And if there are no updates, then I just print HTTP no updates, and if it is okay, then I print HTTP update okay. So we are just handling some cases here, and based on that we are printing the output results. So everything would be handled by HTTP update. So that's what we have included in the above library here. So that will be taken care. Now, how do you add this certificate.h file to your program? So what you can do is you can just click on this drop down here, click on a new tab, and then write down your file name certificate.h, and then you can just copy and paste file, or you can directly go to the folder of this particular program by clicking on the sketch and then show the sketch folder, and here you have both the files present to you. So you can see this, we have both the files present to us here. From here we can do that. So once we have this thing, we save this both. So we are saving this file and also this file. So now both the files are being saved. So we have a ESP32 made custom device here with this. So let us now just try to connect this and see if it works perfectly well. So I have here with me this particular device, and I'll just upload this. To this particular device and see what does it print. So meanwhile the uploading is in progress, we have another file which is a updated version of the same, and it has a version name 2.0. It has a version name 2.0. So let us just try to press a button because we need to have this done here. So yeah, so now it's uploading there, and we'll see the serial monitor here, and the change has been so connecting to the Wi-Fi, and it sees the active firmware version is 1.0 because here we have 1.0 currently. And now what we'll do is we'll go back to this program, that is version 2, and now convert this, save this with an OTA, save this as a .bin file so that we can upload this there. So what I'll do is I'll go to the tools, after going to the tools, what I'll do, sketch, and then we'll write export the compiled binary. So when I click on that, it's going to compile it first and then export this as a binary. So we'll save that file and then upload that file into our GitHub. Anyways, we have already updated our version text. We've already updated our version.txt, so this is done. We need to remove this file and then do the changes. So if I click on this, you can see the view raw data. You can see what do we have in this. So this is completely a binary file, so it just gets downloaded. So here we go, done compiling, it says. Let me just try to do it again. Sketch and export the compiled binary. I think so it's been done. So let me go to the sketch and show the sketch folder. And here you can see that you have a binary, that is .bin file. So I'll just try to rename this. Sorry, I just put in the airplane mode. So what I'll do is I'll just try to rename this. I'll try to rename this by pressing an F2 and then write fw.bin, because my file name there given as fw.bin here, that is in case of our program we are checking out fw.bin, so I'll just rename this particular file as fw.bin. So now this binary file is what we require. This binary file is what we require in this particular thing. So I'll just click on add file. I'll just click on add file and upload a file. And meanwhile I do this, I'll just copy the path to this particular thing. Control C and then go back here, choose your file, and we have this fw.bin. We'll just open this. So now it is uploading in the file there. So let us commit this changes once it is being done. So we're done with this. We'll click on commit changes and it is processing my file. So if I open this again, I have this file. It says it is just being done now. Okay, so now we are done with uploading our .bin file here, and also with the .txt file is updated. So let's just cross check once. Yes, it is 2.0 there. So now going back to our terminal, and then this is our OTA, that is second new version of our OTA. Here you can see this, I have added one extra thing, that is it's going to print a hall read also. It's going to print a hall read. So this hall read sensor is already present in this particular ESP32 by inbuilt. So I'll just pass u here. Because the command given here is u. I'll just pass u here and see. So you can see this, as soon as I press U here, it says new firmware detected 2.0, and let us wait until it is fetching the data and uploading it into the ESP32, and then reboots again, and it should print us firmware version 2.0 there. So here we go, we'll wait. All the files will present in the description down there. You can get your files from there. So you can see that it has booted up. And now you can see this, it says active firmware version 2.0, and this 2732, 9930 are nothing but the hall rate values. So it is now in a new version, that is 2.0. So this is how we can implement a OTA update via a GitHub. We can also do the same thing. Instead of passing a U command there, that is we have just passed U in terminal, instead of doing this, you can also do is directly pass implement a MQTT command, or you have some other trigger based thing, might be some event based, and then call up the same firmware version check and the firmware update and get the thing being done. So this would help you to get the updates really easy and very much handy. So in the next video we'll see how can we do this with a GitLab, and also how can we implement the same thing using the different version or different implementation. For example, might be via an MQTT, or might be via an AWS, or might be via some other cloud, that it receives some MQTT message from the cloud, and then as soon as it receives it, it checks for the update. So that will make it completely remote. From anywhere you just log into your cloud, send a command to update or check the update, and this will check the update and get updated if there is a new firmware being present. So let us just try to do it now and see one more condition wherein Now it is in firmware version 2.0 currently, right? So I'll just try to do the same thing, that is I'll check out again whether it can update again. Okay, it should show me that it is already in the firmware updated, that is new firmware. So let's see this and get to know how it exactly works. So I'll just pass you again here. So you can see this, I have done it and it says device is already on the latest firmware version, so it did not boot up, it just continued the normal process. So with this, thank you for being here, and we'll check back again with a new topic on the next video. Until then, take care.